to this and hook it up to the unit down here and use this to test each one of the positions and do the calibration on it. Or you could use this still without hooking a cable up or any thermometer and simply use reference. That's typically how I do it. It's typically how our technicians do it. I don't want to be bothered with hooking up the cable and having to worry about that. And then you simply go into it. And this allows you to do every one of the positions. With the caveat that right here you see it says vessel number 1, 2, so here's 1, they're labeled 2, 3, and then it goes to 7. If there was a 7 position, but there's not a 7 position attached. So that 7 is this, the probe. If there were 7 positions on here, then the next one, so it's going to go back to 1. If there were 7 positions installed on this, then the 8th position would be the probe. Okay? But that's for adjusting the probe. So if I wanted to adjust it, I simply would come in here, put my reference temperature inside the media, each one of the vessels, and simply turn it up. And this will actually go by hundredths. So you can match exactly what's on here, because this actually goes out to 100ths also. You simply put the number in it.
Low temperature.
You can do low, you got to do a low calibration and then do an upper calibration.
So better both. So
I usually do both. I typically will do the low calibration first, and then of course heat everything back up. The low calibration needs to be about 20 degrees or less Celsius. And then the upper degrees needs to be 37 degrees or more. I typically try to get about 40. So I try to do the first one at lower than 20 and the other one at around 40 degrees. The
screen
upper.
is the same, right?
Pardon?
There is no low screen calibration.
No, it automatically detects.
Yeah.
It detects a difference of 15 degrees. So what it means is if you were to do a low calibration at 23 degrees Celsius, as long as you did the upper one 15 degrees warmer than that, it'll automatically detect and put you into the higher calibration screen.
Okay.
It automatically defaults to high or low. It knows already. You want to try and get below 20 degrees Celsius, and you want to try to get to around 40 degrees Celsius. The reason being, the way this operates, and the way all of them operate that have RTD shafts, it's electronic in nature. This isn't a true thermometer that's on there. It's an RTD. What it does, it measures the change in resistance of the media. The hotter it gets, the change in the resistance increases. So that's how the RTD works on this. So what it does via a programming algorithm, it'll plot. So what you're doing is you're telling it at whatever degree. Say you had it at 18 degrees Celsius. You're telling, when you plug in the number, you're telling it at that resistance, this is what the temperature is. And then you're doing the upper one at 40 degrees, and you're telling it at this resistance, it reads 40 degrees. That way the algorithm inside via programming can plot on a straight line exactly what the resistance should be, what the temperature should be at every single resistance. So all you're doing is you're giving it 2 resistant points of reference so that it can plot via programming. So again, that's why you need to do one below 20 degrees, around 20 degrees or less, and one at around 40 degrees. That way you have a nice linear line for it to plot everything on. Now, like I said, it's simply just a matter of coming in here and doing every position. You set the temperature, whatever temperature is matching on here,